Okay, so this is our next problem here. It's dealing pretty similar where we have helium smacking into nitrogen and then you get something called heavy hydrogen. More or less the same situation we had in the previous video. So let's go ahead and get into it. It says, what is the final velocity of the oxygen 15 atom? Okay, well, again, we're going to use our momentum. And in particular, we're going to look at the x part because, as we've said before, momentum's a vector. So for the x part, momentum final in the x direction is equal to momentum initial in the x direction. Okay? So let's see what we have. We have the heavy hydrogen. We'll call that just H times VH plus, okay, so that's following the collision. There are two atoms. This is HH. I don't even know how you pronounce that, but this guy. And then there's also an atom of oxygen, so we have to include the oxygen. So we'll just say MOVO. Now that's going to be equal to our helium, the momentum from our helium, and the momentum from nitrogen, which is coming from the helium and the nitrogen. That's just what we have initially. So we'll say the momentum from helium times the velocity, and these are velocity is a vector, right? Mass is a scalar, but velocity is a vector. Plus the mass of nitrogen times the velocity. And let's see. So if we look at this, it says that the nitrogen is at rest right here, right? It's at rest. So because of that, we can set this equal to 0. Okay? So that makes it a little bit simpler. And what is it we're interested in? Well, it says we want to know the final velocity of the oxygen 15 atom. In other words, what we want to do is we want to solve for this variable. So we have the mass of the oxygen atom times the velocity is equal to MHE VHE minus just MH times VH. We'll divide by the mass of our oxygen atom. And there you go. This is our expression for how fast the oxygen atom is moving. If you put that in, you'll get about, you can go ahead and plug it in, we have everything, negative 7.79 times 10 to the 5th meters per second. Okay? So that is the oxygen atom's final speed. So that was part A. Now for part B, it wants us to compare and look at the total kinetic energy before and after the collision. Okay, so let's start with kinetic energy initial. Well, initially, we only have what's moving. So we have 1/2 the mass of helium times the velocity of helium squared, and then the nitrogen portion. So 1/2 the mass of nitrogen times the velocity of nitrogen squared. Now, this is initial, and like we said above, the nitrogen's at rest, so there's no velocity here. So this whole portion goes away. So kinetic energy initial is equal to 1/2 the mass of the helium atom times the velocity of the helium atom squared. So if you were to plug all that in, your initial kinetic energy is about 1.008 times 10 to the negative 13 joules. So that's the kinetic energy we have initially. Now we want to know kinetic energy final. So let's see. What we're left with for the final aspect of it, we're left with this heavy hydrogen and the oxygen. So we have the heavy hydrogen and an oxygen 15. So let's put that out. That's going to be 1/2 the mass of the heavy hydrogen, which I'm just calling H, times the velocity squared, plus 1/2 mass of the oxygen, velocity of the oxygen squared. And we have everything, so this ends up being about 4 times 10 to the negative 13 joules. So that's our final kinetic energy. And even though we weren't explicitly given this, we did solve for that in part A, right? So we can actually use that to, we're actually using part A to solve part B, if that makes sense. Everything else we should have good to go. So hopefully that makes sense, how we did that. And yeah.